Welcome to Myth and Talks. Today we will talk about 5th generation of mobile broadband.
What is the 5th generation? 5th generation is the next generation of mobile broadband that will eventually replace, or at least augment, your 4th generation LTE connection. With 5th generation, you'll see exponentially faster download and upload speeds. Latency, or the time it takes devices to communicate with wireless networks, will also drastically decrease. How does the 5th generation work? Like 4th generation LTE, the 5th generation is also OFDM based and will operate based on the same mobile networking principles. However, the new 5th generation New Radio Air interface will further enhance OFDM to deliver a much higher degree of flexibility and scalability. 5th generation will not only deliver faster, better mobile broadband services compared to 4th generation LTE, but it will also expand into new service areas, such as mission-critical communications and connecting the massive yet. This is enabled by many new 5th generation near-air interface design techniques, such as a new self-contained TDD subframe design. Now that we know what the 5th generation is, it's a good idea to understand how it works since it's different from traditional 4th generation LTE. First, let's talk spectrum. Unlike LTE, 5th generation operates on 3 different spectrum bands. While this may not seem important, it will have a dramatic effect on your everyday use. Low-band spectrum can also be described as a sub-1 GHz spectrum. It's the primary band used by carriers in the US for LTE. Mid-band spectrum provides faster speeds and lower latency than low-band. It does, however, fail to penetrate buildings as effectively as low-band spectrum. Expect peak speeds up to 1 Gbps on mid-band spectrum. The high-band spectrum is what delivers the highest performance for 5th generation, but with major weaknesses. It is often referred to as wave. The high-band spectrum can offer peak speeds up to 10 Gbps and has extremely low latency. How fast is the 5th generation? The International Telecommunication Union is a specialized agency at the United Nations that develops technical standards for communication technologies. And it sets the rules for radio spectrum usage and telecommunications interoperability. In 2012, the International Telecommunication Union created a program called INT for 2020 and beyond to research and establish minimum requirements for the 5th generation. After years of work, the agency created a draft report with 13 minimum requirements for the 5th generation in 2017. Here's a general rundown. Peak data rate. 5th generation will offer significantly faster data speeds. Peak data rates can hit 20 Gbps downlink and 10 Gbps uplink per mobile base station. Mind you, that's not the speed you'd experience with 5th generation unless you have a dedicated connection. It's the speed shared by all users on the cell. Real-world speeds. While the peak data rates for the 5th generation sound pretty impressive, actual speeds won't be the same. The spec calls for user download speeds of 100 Mbps and upload speeds of 50 Mbps. Latency, the time it takes data to travel from one point to another, should be at 4 milliseconds in ideal circumstances, and at 1 millisecond for use cases that demand the utmost speed. Efficiency. Radio interfaces should be energy efficient when in use, and drop into low energy mode when not in use. Ideally, a radio should be able to switch into a low energy state within 10 milliseconds when no longer in use. Mobility. With the 5th generation, base stations should support movement from 0 to 310 miles per hour. This means that base stations should work across a range of antenna movements even on a high-speed train. Connection density. The 5th generation should be able to support many more connected devices than LTE. The standard state's 5th generation should be able to support 1 million connected devices per square kilometer. That's a huge number, which takes into account the slew of devices that will power the Internet of Things. What can the 5th generation do? Improve broadband. The shift to the 5th generation will undoubtedly change the way we interact with technology on a day-to-day basis, but it's also an absolute necessity if we want to continue using mobile broadband, remote device control. Since the 5th generation has remarkably low latency, remote control of heavy machinery will become a reality. While the primary aim is to reduce risk in hazardous environments, it will also allow technicians with specialized skills to control machinery from anywhere in the world. Healthcare. The ultra-reliable low-latency communications component of the 5th generation could fundamentally change healthcare. Since ULC reduces 5th generation latency even further than what you'll see with enhanced mobile broadband, a world of new possibilities opens up. Internet of Things. One of the most exciting and crucial aspects of the 5th generation is its effect on the Internet of Things. While we currently have sensors that can communicate with each other, they tend to require a lot of resources and are quickly depleting LTE data capacity. Where is 5th generation now? So, when should you expect to see the 5th generation in your neighborhood? Well, it depends on the neighborhood you live in. Some neighborhoods already have 5th generation access, meaning that all you need to take advantage of the blazingly fast speeds is a 5th generation enabled smartphone. All of the major US carriers are working furiously to build out 5th generation networks, yet deployment across the entire country will nonetheless take several years. Which 5th generation phones are coming out? The first round of 5th generation phones only support some of the 5th generation systems being used in the US, and different models support different bands. So if you want the full 5th generation mix of coverage and speed, currently, the Samsung Galaxy S10 5th generation and Note 10 Plus 5th generation, the LG V50, the Honor Plus 7 Pro 5th generation, the Honor Plus 7T Pro 5th generation McLaren, and a Moto mod for the Moto Z2 Force, Z3, and Z4 are all that's out there right now. Most of those phones focus on the short-range, higher-speed bands. The Note 10 Plus 5th generation for our tandem T-Mobile and the McLaren work on the broad coverage low-speed band, but not the fast high-speed band. It's annoyingly confusing.